Objective 5, identify and draw structural isomers of alkanes, alkenes, or alcohols. So first of all, just a reminder that an isomer is same molecular formula with a different structural formula. So more than one way of drawing the same set of atoms. So with alkanes, we don't see any isomers until we get to pentane because pentane is the first time you can have 5 in a row, and we could take one off and we actually have a middle to put it on. I take that back. We actually could start at butane. So I could have butane with 4. So I always start with the straight chain, and then I decrease by 1, and I only have one place I can put that carbon. If I put it on the top, it's the same thing. If I put it at either end, it's just putting a little bend in it, but it's still a straight chain of 4. So butane has just the 2 isomers. Pentane, now I have 5. There's only one straight chain possible. I can have 4, and I can put it on the second carbon, and that's the only place that one can go, because if I put it on what appears to be the third carbon, it's the second carbon from the other direction. And if you put it on the end, it's still a straight chain. You've just drawn a 90-degree bend in your straight chain. So then my other possibility is to have just 3, and then I'd have to attach both carbons to that center one. So the alkanes are fairly easy to draw isomers for. Even if you get to hexane, again, I follow the same process each time. I draw the straight chain first, so all 6. And of course, you should be drawing the hydrogens in, but I'm not going to take time for that. Then I could have 5 in a row, and I could branch it here. I could also branch it on the center one, so now I've got 2 different ones. I could put 4 in a row, and now I've got 2 to branch off, and I could put 1 on each. Or I could put 4 in a row, and I could put them both on the same one. If I put 3 in a row, I've got a total of 6. Now when I put the other 3 on, I'm actually back to a 4 chain or some kind of a butane group. So there it is for hexane. What's different when you bring in the alkene is you've got a functional group to move around. So ethene is my smallest alkene. There is no isomer for that because there's only 2 carbons. But if I have propene, again, no isomer because there's no place else for that to go and no branches possible off the propene. But when I get to butene, here's my straight chain. Here's my straight chain with the functional group moved. So now I've got 2 possibilities for the straight chain. And now I can draw my straight chain with the carbon coming off. And this one, my double bond could be in any one of these 3 spots, and it's going to be the same looking isomer. So be sure you're looking to see if you're truly drawing something new or you're just drawing a different perspective of the same thing. Put your pencil down. How many can you connect in a row? Alcohols, we have a similar situation going on. If I have methane or methanol or ethanol, I should say, I've got just one place the OH group can go on methanol, just one place it can go on ethanol. But once I get to propanol, now I can put the OH group off the center. And once I get to butanol, I can put the alcohol group off 2 different places on the straight chain. And I can also branch it. And with the branch, I can have the OH off of there, or I can have the OH off one of the ends. So I could make it a tertiary alcohol, or I could make it a primary alcohol. So lots of different options, but you should be able to draw the different isomers given the molecular formula.